Hey everyone! Yesterday I had a happy little accident, so I will be presenting here sitting. So my energy will be mostly hands and voice, woo! And not walking around like I typically do. So I'm Andraž Brodnik, Brodul. I've been a consultant for the last 15 years. First of all, I run a business. I'm not the geek anymore who sits at his desk in the office, just figuring out fancy stuff like Nix and Elm, and so I'm getting more and more customer focused. So I try to serve my customers. I'm jack of all trades, master of some. I'm a sysadmin, SRE, distributing packages, and I'm also a co-host of a podcast called Ogrodje, which is a Slovenian tech podcast. It's mostly in Slovene. In the back there is also Tomaž. He's the multimedia lightning master. So today we will talk about how to put our app in ECS. So ECS is a AWS service or offering, and it all starts with this, right? In the last 10 years, Docker became very popular. We didn't know what to do with all dependencies, so we decided not to pick a better package manager. We just decided to take what the package manager does and just freeze it in a thing called container. And that works pretty well in local development. There are some quirks. It's super easy to create an artifact called the image, the Docker image or container image. But how should we run it in production is the question, because it might not be as easy than copying some code over with SSH and just run it there, right? And the easiest thing is basically to use Docker Compose, which enables us to connect some additional services like the database, and it's the most naive and trivial way to run something in production besides running Docker run. But we might run in some issues. For example, upgrading Docker Compose itself, so the program that is running your production services, or health checks, what happens if your app is unstable, or getting metrics about the containers running, or rolling updates. Maybe you don't want to have a 1 minute downtime when you restart something. And also, for example, high availability is a problem with Docker Compose. So it might work if you have a super small startup, but it might be a bit more complicated if you are running a real production service, international one. So what are the alternatives? Of course, there is always an idealistic marketing solution, the angel from the sky called Kubernetes. But the problem is Kubernetes is quite complex, right? And I started drawing this, and then at one point I was like, yep, there is a lot of things that you need to cover if you want to deploy something basic. For example, it's almost impossible to deploy something if you don't know what the difference between a pod, a container is. If you have some state, then you need to know about persistent volume claims, which are here. PVs, which are persistent volumes, then storage classes. It's complex. So most of my customers do the mistake that they say, we want to have our own Kubernetes. I'm like, that's great, but how many staff will you staff the team with to manage your own Kubernetes? Or at least how many folks will you have to educate the current developers to move to Kubernetes? Because, for example, if you are used to deploy something via SSH to a server, to virtual machine, and you want to use Ansible, for example, it's a trivial migration. But if you want to teach your developers how to run something in Kubernetes or a different scheduler, they need to think completely differently. Basically, they can't take their previous knowledge to the extent that they might with other tools, and just like know what these things are, right? There is a lot of management of how networking works, how disk works, and thinking about how cluster works, and how workloads are distributed across nodes, which usually developers don't really care. Neither do I, neither do my customers. So what are the alternatives? The alternatives are, for example, Heroku, which was bought by Salesforce, and in my opinion, they don't do much with developing their product. It's getting stale, nothing's really happening, they have security issues, they're getting slowly resolved. Then there is Flyo, which is great. If you have a great alternative to Heroku, is a typical platform as a service. If you're running on-prem or your company has servers in your data centers, which is usually quite common in Slovenia, Swarm is a great alternative if you ask me. So Swarm is now built into Docker. It's super simple to create clusters. The only problem that you have there, or the main problem that you have there, it's you will have to take care of distributed storage, but that's also getting simpler with tools like Rook or Longhorn. But the problem again is the same. You will need to have some IT guys or some moderate or intermediate DevOps or operation folks that can help you with taking care of that. It's not just like set and forget, because in 1 year you might have super headaches if you run something like that on your own. So ECS. Why ECS? I would say it's relatively okay, and it's super nice if you're planning to consume AWS services and the ecosystem around it. A lot of us in this region are typically used to maybe use AWS to have EC2 instances, SQS, S3, I don't know, maybe some more services from AWS, but you might miss some services that solve your problem. So don't think of AWS just as a layer that can provide you a queue, blob storage, and object storage. It might be beneficial to use more services than just those. And if you use those services and you use ECS, then EAM is much simpler. So the authentication, how you authenticate, because your app, your Ruby app is running in the ECS cluster, it's a bit easier to authenticate your app that it has access to, I don't know, dead buckets there. You don't, because of course ECS is integrated in AWS roles because it's the same ecosystem. So let's create a cluster. And it's not super complex. You just need to set up a cluster name, and then you need to decide on which infrastructure your tasks will run. And basically, you just set a name. Namespace for us is not so important. And then you can decide between Fargate, which is basically they solve the problem for you. You don't have any EC2 instances, so it just you want to have a task that has 4 CPUs and 8 gigs of RAM. It will just happen. They will provide that for you happily. There is also an option to have Fargate spot instances that will basically be that are cheaper, but they might terminate if AWS is running out of resources. Is similar to EC2 spot instances. You can basically manage your own virtual machines where the task will run on Amazon EC2. This is for some complex stuff. I don't know, maybe you really need a system-wide ultra special way of customizing it or compliance. I don't know what would be the use cases exactly for that. For modern standards, I would just stick to Fargate. And you can also use external instances using ECS anywhere. So you have an option if you have a lot of on-prem servers that you just integrate them into the scheduler of ECS, which is super useful if you are moving, for example, from on-prem to cloud, because if you buy servers, they have amortization period, I don't know, for 5 up to 8 years max. And of course, you can go to your CFO and just say, just throw those out the window because we are now moving to cloud, right? You need to integrate them and then you don't buy new ones. So it's just like, yeah. Just for that you have a feeling, one vCPU per month will cost you for Fargate around $35. And $4 for gigabyte of RAM a month. For example, so if you run a Ruby app with, I don't know, 1 CPU, 4 gigs of RAM, that would be, I don't know, $45. You're a bit limited how you can, which combination of tasks you can create. For example, if you want to have 4 or 16 gigs of RAM, you must also take at least 1 CPU, which makes sense because they want to spread the task load across their physical machine, so you don't hog all the RAM with 0 CPUs. So let's take a look. We now have a cluster, and in order to create a task, we need a task definition. Task definition is basically a template, and the instance of that definition is a task. So yeah, you can't see much, but this is basically the form. If you would click on it, and the things that you need to set is name, image, how big the task should be, nothing super complex, which port should be open. So pretty normal stuff if you are used to I don't know, Docker Compose. It's not something ultra tricky. And all the things I'm doing here for now is just like basically you go to the console and you click around. I tend not to do that at some point because I use then Terraform, but you can totally do it and play around. It's not something that you should be scared of. But there is one problem, right? So tasks can have multiple containers. Usually you have one. It's similar story than with pods and containers in Kubernetes. But the problem is that tasks are basically, once you run them, and if they terminate, nothing will restart them. So they're meant to process batch jobs, for example. And you need something around them, which is marked with X, and that's a service. And the only thing that the service does is it takes the task definition, and you say, I want you to make sure that there will be always 3 instances of that task definition running. So if one crashes, it will basically restart it. And service is also responsible for auto-scaling. For example, here at the bottom, it's written desired task is 1, which is the minimum. But then you can combine those parameters with auto-scaling, for example. So, or you can scale, and it basically takes care of making sure that that the task is always running if it's a service. Like microservice needs to always run, so it will make sure that this is always running. And there's this one last thing, which is, of course, you need to get some ingress traffic, and you do that with a load balancer. So in load balancer, you basically get a DNS entry. So every request that you will send to that domain, so it's the DNS with an IP that might change. Every request that you send there is a rule, and it will then later send to that to a target group, which is ECS service. So You basically get the load balancer, you say, there's a rule, send it to that target group, and that is pointing to the service. And that's everything you need to get started. So cluster, service, target group, and application load balancer. Ruby specifics. You can assign task roles to services. And task roles are basically roles where you can define what your application is permitted to access from that task. Meaning, if you create a task rule, you can access all buckets in S3 read or write. Then the Ruby SDK from Amazon will not need any of the AWS secret keys or access keys. There is a mechanism that it will be permitted to access those buckets. And it's a good practice not in production applications to have two hard-coded values, typically access key and secret key. So you just say, this task has this role, and it's basically the same that you assign the role to a user, and then you export those two keys. It's basically the same mechanism. And that's all for you transparently in the Ruby SDK. One also nice thing to use is, for example, AWS Secret Manager, which is basically just a key value store where you can store some tokens in AWS, so you don't need to hard code them in your application. You just say, okay, maybe I will need a GitHub token, and with the Ruby SDK, the AWS SDK, you can basically just fetch that. You just say, I want that key, and you get the token out. And then if one of your colleagues leaves your company, there's just one place where you replace that token. So you don't need to, it's there, it's audited, you can see who read it, you can see when it was last changed. It's a great thing to have. Yeah, one last thing, if you are using RDS, so the database, you can also assign to the ECS service a security role, and you whitelist that security role in RDS, so you will have a network connection. So security roles or groups, sorry, are basically like you can see it as some kind of firewalls. You basically say all the network from this group to that group will be okay. Otherwise, you won't be able to get any traffic to RDS. I don't know if you have any experience with RDS, but networking to get to the database, there's an additional layer of security that you also need to take care of. You might remember that when you will come to that issue, but yeah, just that you have that on your mind. So a real world example, I will go through that pretty quick, is, so for example, my customer wanted to have blue-green deployments. The setup should be as simple as possible. Who knows what that means? Because it can be 2,000 lines of GitHub actions, or maybe I can just take a tool that AWS provides. We then agree that we will take something that AWS provides. When the container image is created, the deployment starts. So after a pipeline that builds a Docker image, the deployment should start. That's the trigger. And we want infrastructure as code, so that maybe later we will hire multiple engineers that are specialized on reliability. And if we just click as we did it until now, then that's basically unmanageable. And it's also super slow. If you go to consoles and you click that, if I would do that, I would be basically, yeah, it would be too slow. So there is a tutorial. I just followed this tutorial. Just followed, there are some quirks. And what we will need is basically the application load balancer. ECR is an Elastic Container Registry. Think of Docker Hub, just hosted on AWS. Code commit, think of GitHub, just on AWS. Code deploy, that's the magic part. It's a service that handles all the state for blue-green deploy, so you don't have a lot of state in your GitHub actions, figuring out who. Now the new deployment is the green one, and then the next time it will be around because you need to shift, and then when you need to garbage collect the old deployment, there's a lot of state in having blue-green deploys. So blue-green deploys meaning that you have an application running at all times in parallel, and then you just reroute the traffic to the new deployment, and then after, I don't know, 1 hour, you delete the old one, so you can roll back. That means blue-green.
What about if you have a database migrations with this new version?
Oh yeah, that's I don't cover that, but that's a tricky one. Yeah, there are mechanisms that you can run that it handles. I don't know for Rails, but Django has this mechanism that you can basically have green-blue deployments, and then a migration happens on promotion, and they do some magic. But yeah, it's a tricky problem. But there are also ways that whenever you do those steps, you can also trigger, there are hooks, and you can trigger, for example, database dumps. So if you're okay of losing the small amount of data, it really depends on your use case, but it's not a trivial solution. It's case by case. And the code pipeline is basically connecting all the events when we deploy. Just let me. My notes are gone, but that's fine. Yeah, JavaScript presentations are always fun. Yeah, we'll take a look a bit later. So this is how it looks. GitHub Actions built an image and submits it to ECR. That's basically Docker Hub. Then you see there's this code commit thing, and think of code commit, there's just a repository with 2 files. And I need those 2 files so that I can tell code deploy what to deploy. And what are those 2 files? It's pretty simple. So previously we were talking about task definitions. So task definition are the template how you create new tasks. And this is just a normal task definition in JSON. The only thing that is happening here is the image1 underscore name is being replaced by the new version tag and hash. So that's done automatically in code pipeline. You can basically, in code pipeline, you can say, just replace this placeholder with something different. That's one thing that it does. And with that, I know which new service to deploy. And the second file that I have in this code commit is the reference to that newly generated task definition. So AWS, it's a bit old school. Just imagine like you're going to a secretary and you just need to give them papers so they will process something, and those are 2 papers that you need. A task definition for the new service with the new image, and another paper that says, hey, code deploy, this is an ECS service, and this is the task definition that you need to deploy. So if you take a look at the code pipeline, you will see code commit, the 2 files, and ECR are basically the sources, and code deploy is basically the deployment step. And after that, everything is basically managed by code deploy. In code deploy, you can then select, I want a green-blue deploy, I want a canary deploy, I want a in-place replacement deploy. So, and this is how it looks. This is a completed thing. These load bars will fill up. At the start, the original deploy will have 100% of traffic. After a while, the replacement will have 100 if it deploys successfully. If the health checks fail, it will roll back automatically. And then you can specify, I want to have 2 parallel deployments for X amount of time. And all of those things are parameterized, so you can basically set them up as you want. And for everything there, you have hooks, so you can do, for example, migrations, rollbacks of migrations. So traffic shifting is basically managed for you. If you know a bit of Kubernetes, in order to do that, you need things like Flagger or Argo pipelines in order to traffic shift those things. But here, everything is managed for you. You just need to follow the documentation, click things, and it's done. Because we wanted to have this as infrastructure as code, I picked basically Terraform for that. And it's around 600 lines of Terraform to get everything provisioned. You could use pre-built modules for that, but I tend not to because they're covering all the use cases, and I'm not ultra experienced. I wasn't ultra experienced in ECS. Maybe now I can take it. But I decided just to write my own. Now that I have done that, maybe I can take one that are pre-provided, just understand everything that it does, and just use those. But 600 lines is not really that much of Terraform code. I had some issues. I will have to zoom this one up, yeah. And the issues are, for example, you deploy a service, and at one point, code deploy takes over of managing that service because it's doing that automated deployment. And if you want to change that, you will get an error that you can't change it because it's managed by the code deploy controller. So sometimes it happens that you need to modify some life cycles for Terraform resources, meaning that when I first deploy things, they are created, but if I change anything in them, it shouldn't be changed. Basically, it should be ignored, otherwise I get those errors because it's modified by another identity. So there are weird quirks that are happening. And another one is in Terraform, because you are trying to reduce costs while you are developing, you just deploy everything and then you delete the whole stack. Imagine that in the console you click everything, and then you would go, before you go home, you would delete all the resources manually because you don't want to spend too much time, your customers or your own money. You don't want to, I clicked everything here and I don't want to recreate it tomorrow. Of course, you wouldn't do that if you were clicking in AWS console, but if you have it in code, you basically say deploy and then you say destroy. And when I go home, I don't pay the bills if it's not in production, if it's in development. And some of the objects there are getting deleted super slowly. They're basically just marked for deletion, but they will have a status called delete in progress, meaning that I create them, I delete them, and then if I want to recreate them, I will get an error that they are still there. They're just marked for deletion. So it's a bit lazy. That's also a thing that I learned. But after a while, besides this deprecation error, everything started working. And that's super great because now my customer can have, for each branch that they want to deploy, they can have all the setup. Another cluster, whatever their please, is totally isolated. It costs a bit of money. It's maybe, I don't know, $50, $100 per month. But I can now just deploy for every branch their API, and for their use case, That's something that they want. There is also this thing, AWS offers you unlimited scaling until you hit the AWS service quota. That's a thing. So you have quotas on all the resources there or everywhere in the cloud. And for me, it took around 10 days to get that quota increased because the agent in support did an error, so they increased the quota in the wrong region. So that was super painful because then you need to explain to the customer, hey, I asked for that, but there was an error, and then you need to convince AWS that they increased it in the wrong region. So yeah, never open a support ticket on free tier support. You always need to pay at least 50 euros. My problem is that sometimes my customers have AMs, which means account managers. If they're super big, if they're startups, of course, they don't have paid support. So for me, it's always super odd interacting with support from cloud providers because sometimes they're super responsive and sometimes I'm just cursing them all the time and figuring out how to throw money at them so I get things resolved. There was one extra problem. When you submit the image to the ECR, the code pipeline wasn't started, hadn't been started. It was basically not triggering. So I had to create a custom event bridge rule to start that. And that's not in the tutorial. So basically, the tutorial is wrong. I wrote them. I hope they will fix it. Which also tells you nobody's using the solutions that I do, but they are, I guess, super straightforward. And that's it, basically. Yep.
I have a question.
Yeah.
Have you used ECS for a Rails app before, like for a client or not?
I was, so for a production client, not. Here we used basically Python Fast API or the latest framework. I was basically checking it out on my own, just going through the article, Rails getting started, an article. The one thing that I figured out that might be an issue is the environments. I don't know how it's done in Ruby. You have environments and you set fixed parameters, for example, for database. So I don't know how to rotate the passwords for RDS. If I get the password, for example, from the secret manager, I need to make a call to get that password for production. So that was the only thing that I was like, I don't know how to do that. But everything else was basically working. It was not a problem.
And with the blue-green deployments, the one thing I was thinking of is like how asset bundles would work. If you have, a new application with new assets, and then if you don't have sticky sessions, then your clients, if it's a web application, right, like they might not be able to fetch assets if like they get diverted to the new app. Did you read anything about how asset bundles are like?
No, I haven't checked that.
Or whether sticky sessions are an option?
Yeah, sticky sessions are an option. So in ALB, in ALB you can have basically sticky sessions. So I guess if you are being routed to a target group, usually how it works, if you're being, for example, you get an ALB cookie, and then you're consistently routed to a target group. Yeah, but I guess that after half an hour, when the old deployment is terminated, then you will have to switch.
For the blue-green deployment, it'll be mostly new customers that are going on the new code.
Yes.
And then eventually the old customers will be migrated over when you get rid of the infrastructure. How about, you didn't mention Elastic Beanstalk, is that still
it is.
AWS, is that still like a compelling option for this sort of stuff or not? I haven't looked into it.
There is like, I tried So there is something called, so Beanstalk was the initial platform as a service replacement. They now have a Sailboat. There is a new thing that they are offering now, which is called App Runner, AWS App Runner, which will also enable you to have scale to 0. So if you don't have any traffic, it won't even consume any resources.
Okay. Is that like Cloud Run in Google, like where you just upload a container and they give you like an HTTP endpoint or something like that, or is it?
Yes, it's basically like what was the project from Kubernetes, the Knative. They also supported scale to 0 things. The problem, I first tried this AWS. I skip my mind. This one that no, the one that goes to 0. App Runner, yeah. But the problem was that when I was upgrading it to a newer version, it was converting super slowly. So that was not an option for us. It was serving the old app for, I don't know, 40 minutes until it was basically changing it. One thing that I also discovered is that everybody is saying that they're using those things. I mean, ECS, of course, one would think, or AKS probably people are using, but for ECS, I was a bit surprised that some things were basically just missing from the tutorial.
I thought ECS, what was the order? Like ECS, then EKS, and then Fargate? Is that when they were released? Because I know ECS came first before EKS.
Yes.
And then I think a lot of people decided to use EKS when it came out.
So
that they could do, because I think what's missing in ECS, from what I see, is like you can't duplicate it locally on your laptop, which is kind of a pain if you're a developer. Like I want things to run exactly the same locally, and with all this stuff with ECS, it's a black box.
Yeah. AWS has a super strange history when it comes to serving containers. They didn't have, so 4 years ago everybody had super advanced script that deployed Kubernetes to EC2 instances because they were basically lacking an in-house solution for Kubernetes. So Google Cloud really got a lot of customers. Then they deployed ECS, which is their own solution, which I think is nice, especially if you are consuming other AWS resources or services. And then AKS they added later, which is basically a native Kubernetes API. But yeah, at least for me, if you don't have any experience with Kubernetes, I would say that this might still be quite simpler than going the whole Kubernetes way, because I was underestimating Kubernetes a lot, and then it's basically a normal thing that you have operators that are injecting containers in your pods. It's if you really want things to work, but here I think that it might be a bit easier if you are just want to deploy an app. Any other questions? Yeah.
In regards to this blue-green deployment and the gradual traffic routing, so what happens if you have like a separate API and then you have like front-end client that's not like that's running on S3, like serves through S3 or something like that? Do you need to then ensure like backwards compatibility if there's like two versions of the API running at the same time, I guess, during deployment, so to avoid like requests failing if it would be compatible, is then this just not an option, or do you need to like have it always backwards compatible or something like that?
Yeah, that's yeah, you need to version the API usually. It's also when it comes to blue-green and canary deploys, when you say traditionally blue-green will mean that you switch all the traffic. canary will mean that you basically reroute a percentage of traffic. But that's very academic. It doesn't really matter because it's really depends on your problems. So what you are dealing with. In this case, for example, there were machines talking to the API, and there were no persistent sessions. It was a RESTful API, so machines were just like pulling down some data. The authentication mechanism is super simple, and you don't have a lot of this state management problem. When it comes with, if you have two teams and you have a backend team and a front-end team, and you are basically doing this task, if your API is not backwards compatible, then technically you should increase the version. And it's super funny, 99% of startups that I work for, they have a versioned API, so it's a V1, but I never seen it increased. Right? But what you usually do, you basically, at the router, you just say, okay, V1, and we will make sure that most of the time it's backward compatible because it makes sense, right? And then you just run 2 router paths for a while until you are pretty sure that the clients are gone. It can take also years. If it's a front-end app, it's simple, right? But if your front-end is basically a CLI tool, then your customers might need some time that they upgrade, and you just then run that for a while, and then after the while you delete that out because
Disgusting.
yeah, because otherwise you have the problem as with feature flags. There's basically dead code for the next 5 years because nobody deleted the version 3, and you are now on version 5, right? But those are quite advanced topics, I think, and you need really to take a look from case to case. It's completely different. There's no silver bullet. It's tricky.